Welcome. Today we are introducing A2H, the Agent-to-Human Protocol. We talk a lot about agents talking to agents, but today we're focusing on a critical missing piece, integrating humans as addressable nodes within autonomous agent ecosystems. It's time to bring people into the network infrastructure. Let's look at the current state of things. On the left, we have the connected stack. We have LLMs, APIs, enterprise apps, and protocols like MCP standardizing how machines talk to machines. It's efficient, but it's a closed loop. On the right, we have the void. Currently, humans are treated as unresolvable entities. We are external observers. When an agent hits an impasse or needs help, it lacks a standard mechanism to discover or address the right expert. There is a gap between the silicon and the user. The A2H model represents a paradigm shift from human as trigger to human as node. In the old model, the human prompts the bot and waits for a response. The human is just the trigger. In the A2H model, humans are treated as resolvable, discoverable entities. The agent can initiate a query to a registry, find the right person, and send a call to them. It turns the interaction into a loop where the agent can proactively reach out to us. So, how does this work? The protocol consists of three fundamental layers that ensure agents know who to ask, when to ask, and how to ask. First, the identity layer, the human card. This handles capabilities and discovery. Second, the logic layer, the communication schema. This defines decision constraints. And third, the transport layer, the unified messaging abstraction. This handles the translation between JSON code and the UI you actually see. Let's zoom in on that first layer, the human card. Think of this as DNS for people. Just like a server has an IP, a human user has a structured metadata registry. In this example, an agent can perform a semantic search to find Alice. It knows she is a senior engineer, it knows she has the capability for deployment_approval, and it knows her endpoint is Slack. This allows agents to route tasks dynamically to the right person. Next is the logic layer, the communication schema. We want to minimize cognitive load, so we define strict triggers for when a human is actually needed. The agent checks its state. Is confidence below a threshold? Is the action high risk? Has the loop limit been exceeded? If the answer is yes to any of these, it requests a human. If no, it continues execution autonomously. This stops the agent from bothering us with trivialities. When the agent does reach out, it uses four specific interaction primitives. 1. Permission, for high-risk, irreversible actions. This is a hard block until approved. 2. Clarification, when there is ambiguity. This is a soft block, asking option A or B. 3. Solicitation, when information is missing, like needing an API key. 4. Notification, just a non-blocking update to say a task is done. Efficiency is key here. We decouple communication logic so agents don't idle wastefully. In a sync or blocking pattern, the agent sends a request and just waits. This burns resources. In the A2H async pattern, the agent sends a request, serializes its state, and goes to sleep. It only wakes up when the human responds via a webhook. This allows for long-running collaborations without tying up compute. Now, the transport layer, the unified messaging abstraction, or UMA. This acts as a translation layer. The agent generates complex JSON code, like a clarification request with options. The UMA layer renders this into platform-native UIs. So, the agent speaks code, but the human sees a nice Slack message with clickable buttons for option A and option B. Let's see this in action with a DevOps case study. Context: an autonomous agent monitoring a server detects a memory leak in Kubernetes. It needs to coordinate a fix with Bob, a human senior site reliability engineer. The agent uses the protocol to bridge the gap between the server crash and Bob's Slack. First, the agent queries the registry for someone with the Kubernetes tag. It finds Bob. The agent identifies 2 potential files to fix but hits an ambiguity trigger. It can't decide on its own. So, it sends a message to Bob via Slack. Which file should I patch? Presenting 2 clear buttons, Patch Production or Patch Canary. Bob selects the file. Now the agent needs to restart the service. This is a high-risk action. It is gated by the protocol, not just prompt engineering. The agent presents a critical authorization card. It shows the action kubectl rollout restart and the expected memory change. It waits for Bob to click the big red Approve Restart button before resuming. Why go through all this trouble? Let's compare a baseline chatbot to an A2H-enabled agent. A chatbot relies on manual addressing, you have to be in the chat. A2H uses dynamic discovery to find you. A chatbot hallucinates or loops when confused. A2H uses structured solicitation. A chatbot dumps raw text. A2H uses native UI components. And most importantly, a chatbot has no real guardrails. A2H forces formal permission gates for safety. The A2H protocol standardizes collaboration in 3 ways. 1. Discoverability. Humans are no longer invisible. We are resolvable nodes in the infrastructure. 2. Safety. Irreversible actions are blocked by protocol state, making human oversight mandatory. 3. Usability. Agents communicate through rendered, clickable interfaces, not raw JSON blocks. In conclusion, A2H moves us toward human-connected intelligent infrastructures. We are advancing AI agents from being isolated tools into truly collaborative team members. Thank you.